Hello, welcome back to the channel. So let's move on to a new concept which is based on evaluating indefinite or definite integrals of trigonometric functions in this case. So in this video and in the upcoming videos as well, we will be using the strategies that we learned in the previous videos and solving the indefinite or definite integrals of trigonometric functions only. So we'll have a combination of trigonometric functions in these type of questions, and then we'll be using either substitution or the normal method or even integration by parts in order to solve these type of indefinite or definite integrals in this case. So before watching this video, I would highly suggest you to first watch my previous videos on these concepts, the concepts of normal integration, substitution and integration by parts, in order to get the full context of what we will be dealing with in this video. So let's move on to the question now. So the question is about evaluating the integral of secant to the power nx tan x dx, where n is a strictly positive integer. So n is greater than or equal to 1. So now let's write the integral again. The basic integral is secant to the power nx tan x dx in this case. And in this case, we can clearly realize that since we have secant x and tan x, it gives us an idea that it might be a substitution question over here, right? Because we know that the differentiation, the derivative of secant x has a tan x component, and so is the case with tan x as well. If we take the derivative of tan x, it's secant square x. So that is why it gives us an idea that it might be favorable to use substitution in this type of indefinite integral calculation. But now the main question is, what do we choose our u function to be? You remember in these type of questions, we used to first assume a function u and then do all the substitutions based on the u function, right? And similarly, in this case, since we will be using substitution in order to solve this indefinite integral, we'll have to assume a u function. And in assuming our u function, we have two options. We can either assume our u function to be secant x, or we can assume our u function to be tan x. So let's write both the ways and see which way is the most favorable in this one. So we can assume u to be secant x, or we can assume a u to be tan x as well, right? And we know that if we take the derivative of u with respect to x in this case, this is secant square x. If we take the derivative of secant x in this case, it is secant x tan x over here, right? So now, if we take a u to be tan x, our integral would become, so this can be changed to integral secant n minus 2 x secant square x and then tan x dx, which was already over there, right? If we take our u function to be tan x, we can simply write this integral because we want a secant square expression over here. So that is why I split this secant to the power nx into two parts, which are secant to the power n minus 2x times secant square x, which is secant to the power nx only. So now if we assume our u function to be tan x in this case, we can write secant squared dx. If we move the dx over to this side, we can write the secant squared dx as du. So this will be changed to du, but we are still left with the secant to the power n minus 2x component, right? And if we move forward with this case, we don't have any option to adjust this secant to the power n minus 2x term and include it in the substitution expression over here, right? Because we know that a u is tan x, so we can convert the tan x to u. We also can convert the secant squared dx term to du, but we don't know what to do with this term, secant to the power n minus 2x term, if we assume our u function to be tan x in this case. So this approach might not be a favorable approach to go with, right? So that is why let's try solving with this approach over here. If we assume a u function to be secant x, our du is secant x tan x dx, right? So let's write the integral expression again. The integral expression is secant nx tan x dx, right? So now since we are assuming a u function to be secant x and we want a secant x tan x component as well, so let's have a secant x tan x component over here and split this secant to the power nx in order to get the expression that we want. So we can split the secant to the power nx as simply secant to the power n minus 1x times secant x and with tan x dx as well, right? So now we have secant x tan x dx over here, which can be easily transformed to du over here, because if we assume a u function to be secant x, our du is simply secant x tan x dx, right? So this would be easily changed to du in this case. And again, since we assumed a u function to be secant x, this expression over here can be simply changed to u to the power n minus 1, right? So that is why if we follow this approach makes our integral much more simpler, right? As compared to this one. Because if we follow this approach, we don't know what to do with this term over here, right? But if we assume this substitution over here, if we assume a u function to be secant x in this case, we know what to do with each and every term of this integral expression, right? So if we move forward with assuming u equals secant x, our du is basically secant x tan x dx, right? I just shifted this dx over to the other side. So du is secant x tan x with a dx over here, right? And now let's do all the substitution. So our final integral would be secant to the power n minus 1 x would simply become u to the power n minus 1. Secant x tan x dx would become du in this case. So this is du. And this integral over here is very simple to solve, right? We can simply use the power rule of integration in order to calculate the answer to this indefinite integral over here, right? So let's do that. So according to the power rule, if we are calculating the integral of u to the power n minus 1 du, it would simply be u to the power n minus 1 plus 1 upon n minus 1 plus 1, right? And then we'll add a constant of integration as well, because we are calculating an indefinite integral in this case. So our final answer, according to the u function, would be simply u to the power n upon n plus c. But now, since we want the answer to be in terms of x over here, because we have a dx component over here, so we need our answer to be as a function of x, we'll have to substitute the original function back into the u expression over here, u expression in the final answer. So since our u is secant x, our final answer to the original indefinite integral would be secant to the power nx upon n plus the constant of integration in this case. So that's it for this video. Again, in order to solve this integral, we used the basic concepts of substitution that we already covered in the previous videos. So the only big thing about this question was to identify which function is the u function in this case. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.